This is the Databricks Data Engineer podcast. Your platform team just made Liquid clustering the default for every new Delta table, and somewhere on your workspace, there are 600 older tables that were partitioned and z-ordered before Liquid clustering existed, and nobody on your team will give you a clean answer about which ones to migrate. By the end of this episode, you'll have a 4-question filter you can run table by table to decide which ones get Liquid clustering, which ones keep the partitioning they already have, and which ones genuinely should not be touched. Let's get into it. A scene I want you to picture, because if you own Delta tables in 2026, you have already lived this exact morning. You open your workspace. 2 tables are sitting in front of you. They're the same size. Both are around 800 gigabytes. Both serve the same downstream business intelligence workload. From the outside, they look like twins. Table A was created in 2023. It was partitioned by event date. Z-ordered on user ID. Somebody designed that layout on a whiteboard. They argued about cardinality. They picked the partition column based on what query patterns the analytics team said they had at the time. The table has been in production for almost 3 years. It runs fine. Table B was created last quarter. Greenfield, the platform team's new template ships with Liquid clustering on by default. Nobody picked a partition column. Nobody whiteboarded the layout. The table just started absorbing data, and the engine started maintaining the clustering layout incrementally instead of asking a human to predict the right partition key on day 1. You're staring at both of them. Your tech lead sends you a Slack message. Migration tickets for the partition tables. How aggressive do we want to be? And there is a real chance right now that whatever you type back is going to be wrong, because the question your tech lead just asked is the wrong question. The right question is upstream of that one, and it's the one that gets skipped in almost every migration meeting. The question is this: what actually changed underneath you when Liquid clustering shipped? And the honest answer is that this is not a feature swap. It is a paradigm shift, and the migration math only makes sense once you see it that way. Let me name the shift, because once it has a name, you stop arguing about features and start making real decisions. For the last decade of data engineering on Spark, the human designed the data layout. You picked the partition column on day 1. You picked the Z-order keys. You read the query patterns the analysts told you about, and you compiled all of that into a layout decision that lived in your create table statement and basically never moved again. The layout was static, it was designer shaped. The engineer's job was to predict the future query pattern at table creation time and bake it into the physical layout, and then hope you were right. Liquid clustering inverts that. You still declare the clustering keys, but the engine maintains the physical layout incrementally as data lands. And on Unity Catalog managed tables with predictive optimization enabled, the engine will even pick and update the clustering keys for you based on the actual query history. The layout adapts to what is actually getting asked of the table, not what somebody guessed about it in a planning meeting 18 months ago. Static became dynamic. Designer-shaped became workload-shaped. The center of gravity moved from the human at table creation time to the engine at write and query time. That is the layout pivot. Designer-shaped to workload-shaped. Static commitment at creation to ongoing adaptation at runtime. Write that down. Save it. Quote it in your next design review. Because the entire migration debate, every ticket on your board, every greenfield decision for the next 2 years gets a lot simpler once you can name what actually changed. Now, here is where most of the content you have read on this so far stops, and where the actual decision starts. If the layout pivot were a clean upgrade, this episode would already be over. Migrate everything. Default greenfield to Liquid clustering. Tell your boss you saved the company money. We could go home. But here is the part the evangelism crowd does not say out loud. Workload-shaped layout is not strictly better than designer-shaped layout for every table you own. There's a real named set of cases where the old paradigm still wins, and if you migrate those, you make things slower, more expensive, and harder to operate. The Migrate-everything reflex is just as wrong as the Migrate-nothing reflex. Both of them are skipping the actual decision. I used to think the right move was ordering on basically every table, then liquid clustering shipped, and the easy overcorrection is the other way, flipping the default to liquid clustering for everything. Both of those defaults are wrong. The right default is per table, and there is a small filter that gets you there. So here is the filter. 4 questions. You ask them table by table. The answers narrow your decision from a debate into a call. Question 1. How big is the table, and what is its right pattern? Liquid clustering earns its keep on tables that are large enough for clustering decisions to matter, and active enough for the engine to learn from. If the table is tiny, the engine has nothing to optimize, and the overhead is not worth it. If the table is enormous and append-heavy with consistent query patterns, this is where workload-shaped layout shines hardest, because the engine keeps the layout aligned with the queries as they evolve, and you do not pay for being wrong on day one. Quick objection, because somebody listening is already thinking it. Yes, very small tables do not need either of these. If you have a dimension table that fits in memory and gets scanned in full, you do not need liquid clustering and you did not need z-order. Both are overhead. Default to leaving small tables alone. Save your attention for the tables that actually feel expensive. Question 2. What is the query shape? Be honest about how this table actually gets read. Is it filtered on the same 1 or 2 columns every time, with a clear access pattern, by the same dashboard for years? Or do the access patterns shift, expand, surprise you, with new columns getting filtered as the business evolves? Designer-shaped layout assumes you know the query pattern at creation time. Workload-shaped layout assumes you do not. If you genuinely know the queries and they have not changed in 3 years, the old way costs you nothing. If the queries drift, designer-shaped layout drifts out of alignment, and you pay for that every query. Here is the objection I always hear. But we know our queries. Sometimes you do. Sometimes you knew them in 2023, and the business changed in 2024, and nobody updated the partition column. The honest test is whether your filters today match the partition you picked. If they don't, the layout is already drifting and you are already paying. Workload-shaped layout closes that gap automatically. That is the actual feature. Question 3. What are the retention and compliance constraints? This is the question that saves you from making a clean, principled migration that breaks your operations team in 6 months. Partition columns are not only a query optimization. They are an operational tool. If you delete by date because of a retention policy, partitioning by date means a drop partition is cheap, predictable, and fast. If you have to honor regulatory deletes on a specific column, partitioning on something aligned with that delete pattern makes the deletes physically isolated instead of spreading them across every file in the table. Liquid clustering does not give you that. And here's the part you have to remember. On a delta table, liquid clustering and partitioning are mutually exclusive. You pick one. You do not stack them. So if your table's lifecycle is driven by drop partition operations, or regulatory deletes on a known column, keeping the existing partitioning is not a legacy debt. It is the right design for the table, and migrating it to liquid clustering means you give up the operational property that justifies the layout in the first place. The first time you migrate a regulatory table to liquid clustering, and then your compliance team asks why the deletes now scan a much larger surface, you will remember this question. Ask it before you migrate, not after. Question 4. What does the cost of switching look like for this specific table? Some switches are cheap, some switches are not. Switching a small or medium table to liquid clustering can be a relatively low-cost change. switching a multi-terabyte production table that is partitioned, z-ordered, governed under Unity catalog with column masks, and feeding 3 dashboards and a finance close. That is a project. It is a project with a rollback plan and a change window, and a comms thread with downstream owners. The reversibility of the switch is not the same for every table on your workspace. The cost of being wrong is not symmetric, so the order matters. Migrate the cheap, high-value tables first. Defer the expensive tables until you have evidence from the easy ones. Those are the 4 questions: size and write pattern, query shape, retention and compliance, switching cost, run them table by table. That is the filter. Now let me name the surviving cases for the old paradigm, because this is the section that gets cut from most content on this topic, and it is the section that saves your operations team. Case 1. Regulatory delete patterns. If your table lifecycle is driven by deletes on a known column, partitioning aligned with that column is a feature, not legacy debt. The deletes stay physically isolated. The operations team can reason about them. You do not give up that property just because there is a newer mechanism, and you cannot bolt liquid clustering on top of it anyway, because on a delta table you pick one layout, not both. Case 2. Retention-driven tables. If you drop a window of data on a schedule because of a retention policy, partition by the column that schedule is driven by. A drop partition is operationally cleaner than a delete plus rewrite, and that operational property is exactly what liquid clustering is not designed to give you. Case 3. Very small tables. If the table is small enough that a full scan is fine, neither liquid clustering nor z-order is earning its cost. Leave it alone. Your attention is more valuable than the optimization. Case 4. Excess patterns, liquid clustering does not serve well. This one is the most subtle. Liquid clustering shines when queries filter on the declared clustering keys, and when the table is large and active enough that file skipping matters. If your table is read mostly through full scans or through patterns that do not benefit from data skipping at all, neither liquid clustering nor z-order is buying you much. The honest answer there is to stop optimizing the layout and look at what is actually driving cost on that table. The wrong move is to migrate to liquid clustering and report a win that does not exist. I want to give you one named tool to carry out of this episode, because 4 questions in your head will fade by Friday. The tool is the layout pivot audit. You take any table on your workspace. You ask the 4 questions in order: size and write pattern, query shape, retention and compliance, switching cost. You write down the answers. You assign the table to one of 3 buckets: liquid clustering native, which means greenfield, or a clean migration with no operational constraint that pins you to partitioning. Partition stay, which means the table belongs to one of the surviving cases for the old paradigm, and you leave the existing layout alone. Or defer, which means the answer is not yet obvious. The table is large, expensive to switch, and the value is not clear enough to justify a migration ticket yet. Park it. Come back after the easy migrations have given you evidence. That is the audit. Layout pivot audit. 3 buckets. Liquid native, partition stay, defer. You can run it on a single table in a minute. You can run it on a backlog of 600 in an afternoon, and you walk into the next migration meeting with the only thing your tech lead actually wants, which is a defended decision per table, not a blanket policy. Let me close the loop back to the 2 tables we started with. Table A, the 2023 table, partitioned by event date, z-ordered on user ID, 3 years in production, run it through the audit. If event date is also a retention driver, and you actually drop old partitions on a schedule, it goes in partition stay. The existing layout is doing operational work that liquid clustering would not give you back. If event date is purely a query optimization and the queries have changed, the table is a candidate for liquid native, and you migrate it with a clustering key chosen against today's filters, not the 2023 ones. Either way, you have a defended answer, and you can put a number on the cost and the value of the change. Table B, the greenfield table, liquid clustering by default. Run it through the audit too. Yes, even the greenfield ones. If it has a regulatory delete pattern on a known column, the right design might have been partitioning on that column instead of liquid clustering. And you have to decide whether to recreate the table or accept that deletes will scan a wider surface. The platform team's default is not the right answer for every table. It is the right answer for most of them, and the audit tells you which ones it is wrong for. That is the layout pivot in practice. Designer-shaped to workload-shaped, with eyes open about the surviving cases for the old paradigm. Not migrate-everything, not migrate-nothing. Decide per table with named criteria in language your tech lead and your platform team and your compliance team all understand. One more thing before we close. The career stakes here are real, and they are not about knowing the latest feature. They are about what kind of engineer you are in a design review when somebody asks the migration question. The engineer who says liquid clustering is the new default. Let's move everything. Sounds current, but is wrong about a quarter of the table catalog. The engineer who says, we already partition, let's not chase the new thing, sounds principled, but is wrong about most of the table catalog. The engineer who can name the layout pivot, walk through the 4 questions, and assign each table to a bucket with a one-line reason. That is the engineer, the lead, and the architect remember when promotion conversations happen. That is what tool selection actually buys you. Not the technical answer, the credibility of being the person who can see both paradigms and choose between them on purpose. That's what I've got for you today. Here is the homework. Pull up your workspace tomorrow morning. Pick 3 tables. Run them through the layout pivot audit. Liquid native, partition stay, or differ. Write the answer next to each table. If you cannot answer one of the 4 questions for one of the tables, that is also useful information, because it tells you which conversation you need to have first. And one wider thought to take with you. Every few years, our profession quietly moves a decision from the human to the engine, from manual partition design to liquid clustering, from hand-tuned cluster configs to serverless, from custom orchestration to managed workflows. The pattern keeps repeating. The skill that compounds is not memorizing the new default. It is being the engineer who can name what moved, see the cases where the old paradigm still wins, and make the per table call without flinching. If this one landed for you, send it to the data engineer on your team who is staring at the migration ticket right now. See you next time.